Yeah. Yes. On the ones that are remained in this bigger bottle. Are we clear? Now I want you to understand the second thing now, right? So that second thing is this. If maybe sodium is reacting with chlorine, what does that give us? Sodium chloride, like that, right? So it means that what must be done to the now it is balanced, right? What you have to do now, or what I want you to understand, is this. When elements are reacting, they react according to how they are saved, right? What I'm trying to say is this. Just let's take an example, ne? A very short example. Ne? In that Sasco bread, how many slices are there of bread? 18. Hey, so it means that you're counting. You're counting. Okay, so in that Sasco bread, right? There are how many? There are 18 slices of bread, right? Yes. There are how many? 18 slices of bread, right? So let's say I'm going to eat this bread with what? With cheese, right? So I'm going to take 2 slices of bread and put only 1 cheese inside, right? So at the end of the day, how many pieces am I going to make that side? If I'm taking 2 slices of bread with one slice of cheese, I'm going to have 9 of those 2 pieces, right? Is that correct?
So you have only 1 cheese.
Okay, I'm trying to make sandwiches, right?
Yeah, it's 9.
So it's 9, right? How many? 9. Okay, so I'm going to make 9. So what about if I was having 10 slices of cheese? What's going to happen? One was going to remain, right? 1 slice of cheese was going to remain. So if 1 slice of cheese was going to remain and 18 slices of bread were going to be used up, right? You don't understand where the 9 is coming from.
You said you have only 1 cheese. 1 cheese.
No.
Did you say you only have 1 cheese?
No.
Oh, I thought maybe you said you have only 1 cheese.
No, we are having many cheese, but we are doing what?
Using 1.
You are using 1 per 2 slices of bread, right? If that is happening, what's going to happen now? We said we are going to have 9 sandwiches, right? Yeah. Is that correct? Yeah. Okay. Now, what happens if I'm having 10 slices of cheese and 18 slices of bread? How many sandwiches am I going to create? 9. But I'm going to have 1 leftover cheese. Is that correct? Yes. Did you understand that? Yes. I'm going to have what? 1 leftover cheese. So what can I say now about cheese and the slices of bread? It means that cheese was in excess. We're having many cheese than required, right? Yes. We're having
many cheese
than required, right? So we call that excess. So we say cheese was in excess. We're having more of that, right? So here I'm trying to make you understand about the excess reagent and the limiting reagent. So it means that bread is the what? Limiting reagent, because it is the one that finished up earlier. Is this making sense? Yes. Is this making sense?
100%.
100%. So what is the limiting reagent?
It's the substance that is completely used up.
Substance that is completely used up, right? In a what? In a chemical reaction. So excess is the one that remains after the what? The reaction has been completed. Is this making sense? Is this making sense? Is this making sense? Yes, right? Okay. So now let's take it that I'm having 24 slices of bread. Right? I'm having 24 slices of bread. So there are 24 now. But now I'm having what? I'm having 11 slices of cheese. What's going to happen? I have
Two slices are going.
The cheese is going to be limiting agent.
the cheese is going to be the limiting factor, right?
Yes.
And then the bread now is going to be in excess.
Yes.
Because from 11 cheese, we require how many slices of bread? 22. Right? So it means that 2 are going to remain. Is this making sense? What I'm trying to make you understand?
Yes.
So it means that now we're just talking about the what? The limiting and the what? And the excess.
Yes.
Right?
Yes.
So in chemistry, we are going to use a lot about limiting reagent and the what? And the excess reagent, right?
Yes.
And I helped you to understand what is that. So now let's take it to having sodium reacting with that, right? And I said 100 grams of sodium, right, is reacting with maybe 150 grams of chlorine, like that, right? And I ask, how much of this is going to be created?
In terms of what? Mass.
Yes. So now what do you do?
Just calculate the number of moles, then we'll check which one is the limiting reagent. After then we'll use the motion, the ratio. Yeah, mole ratio.
The mole ratio, right? So how do you find the limiting reagent here?
Number of moles.
First, we have to find the number of moles of each, right? And then what do we do next? We do what? Let's see. Let's find the number of moles of each, right? So what is the number of moles of sodium? Is mass over what? The molar mass. So this is sodium, right? So the number of moles of sodium becomes what? What is the mass of that? 100, right? Over, and then the molar mass of sodium is what? 23. And what about these two here? Kulis, what about these two? We don't include it, right? Because this is a what? A coefficient. We don't include the what? The coefficient, right? So it means that this becomes what? 23. So what is our number of moles?
4,35.
4,35 moles, right? What about chlorine now? Let's do the same, right? We can find the number of moles of what? Of chlorine. How to find the number of moles? Still number of moles is equals to mass over molar mass. And this is what? Chlorine. So this is number of moles of chlorine being equals to, what is the mass? 150. What is the molar mass of chlorine?
35,5.
But now we're having what? These two now matters, right? We're going to include it in finding the what? The molar mass of this. So what do we do?
35,5 times 2.
Which you get what?
2,11 moles.
Yeah?
2,11 moles.
No, I mean 35,5 times 2.
Oh, 35,2.
35,5 times 2, what do you get?
71. Yeah, 71.
71.
It's 71.
Yes.
So now what is our number of moles? It's 2,
1,1
11
moles.
moles.
Yes.
So these are the number of moles created, and these are the number of moles created there, right? Which one is the limiting reagent? How?
By mole ratio. Maybe just check on sodium.
Yes. How do you do that?
We're going to compare them. We're going to compare sodium and
So what you do is that we compare them on their what? On their simplest terms. We compare them on their what? Simplest terms. This one is only 1 created, and this one is 2. So it means that we have to divide this one by 2 to get the number of moles while it is on 1:1 ratio, right? And then we can compare the one with more, then it is the what? The excess. The one with less, then it is the what? The limiting, right? So it means that this one we're going to divide it by what? By 2, right? So a number of moles becomes what? If we divide this by 2,
2,175.
175. So now we can decide which one is the limiting.
Which one?
So it means that now chlorine is the limiting reagent, right? So now after finding the limiting reagent, it means that we can calculate whatsoever that we can calculate, right? So the most important thing is to find the what?
the number of moles.
Which one is the limiting and which one is the what? The excess, right? Because it means that if this is the limiting, so it means that it is the one that stops the reaction, right? Because the reaction happens on the 1:1 number of moles, right? So it means that if 2 moles of this are used up, and also here this side how many moles are used up? 2 as well. Do you understand that? So it means that here we're going to use up how many? 2,11, right? We're going to use up 2,11, and also this side we're going to use up what? 2,11, right? So what is the excess number of moles there? We were going to say 2.175 minus 2.11, right? So that is the excess. What do you find?
Is 0,065. Yeah.
That is the excess. So it means that after the reaction is completed, this is the number of moles of what? Of sodium that are going to do what? To remain, right? But okay, yes, I just wanted you to understand further, right? But now let's talk about the what? The number of moles there, right? We said this is the what? The limiting reagent. So if you're having the limiting reagent, you can calculate the number of products created, right? So it means that this is the limiting. Which one is the limiting? Right? So 1 mole of chlorine is producing how many? 2 of sodium chloride. So they are happening on a reaction of what? 1:2. So it means that if we are having 0.5 moles of this used, we're going to create what here? 0.5 multiplied by what? By 2. Can you see that? Who are you still here? And if here we have created 1 number of mole, then we are going to create what? 2 number of moles. If we have used 6 this side, how many are we going to create? 12, because they're happening on the reaction of 1:2, right? So it means that here we have used 2.11. What are we going to create that side? So here we're going to create 4,22 moles. Can you see that? Can you see that? Or we can use this reaction, this formula that says Na over A is equals to Nb over B. So N is the number of moles of that reactant, right? Over the what? The coefficient. What is the coefficient there? 1. And then here it is the what? The number of moles of something that we're trying to find this side, right? And B is the what? Coefficient, right? So we can also use this formula and we're still going to find this answer there, right? So number of moles of A, what is the number of moles there? 2,11, right? Over the coefficient is equal to the number of moles there. So this is sodium chloride, right? Over the coefficient there, it is what? 2, right? So it means that the number of moles of sodium chloride will be equal to 2 multiplied by this, giving us. Can you see that?
Yes.
Can you see that? Can you see that?
Yes.
Is this making sense?
Yes.
So this is when we are not told that things are completely neutralizing each other. So if 2 things are completely neutralizing each other, that's a different aspect that we deal with, right? But once they just tell you that whatsoever number of moles and whatsoever number of moles are reacted and creating the the products there. It means that first we must find the what? The limiting reagent. Is this making sense? Okay, let me just put out another example. The number of moles, yes, you can write like this. You can use this formula. You mean the whole thing from start? Okay, we are going to do that, né? And you're going to see how we can work on that. Here, I just want you to see, like, to have insight on this topic, right? Because this topic, if you are misinformed or if you are not informed well enough, you're going to get wrong things. Because you won't be having all information, right? Topic learning the equation. At the previous years, they used to give you to balance the equation on your own, right? But I think now they're being more polite. They balance the equation for you. But you also have to learn how to do what? To balance equations, right? Try to find the question papers from many years ago. Ne? Try to balance those equations. The more you understand how to balance the equation, the more you understand what? Your chemistry, right? Okay, so let's see now. We're having what? We're having sodium chloride reacting with water, right? Giving us chlorine plus sodium hydroxide, right? So we're getting sodium hydroxide. So they're asking what is the maximum mass of sodium hydroxide that can be obtained from 4 kgs of sodium chloride and 3 kgs of what? Of water, right? So if we're having a situation like this, if they're asking you for the maximum what that is going to be created, ne? If they're asking us something like that, so it means that our best chance is to first do what? To find the number of moles of these two and find which one is the what? The limiting reagent. And then after finding the limiting reagent, we are going to use that limiting reagent to find the what? The product that they are trying to find. Are we together? Yes. So it means that we are first going to find the number of moles of these two. And then we compare which one is the limiting and which one is the what? The excess. Right? So let's see. So what is the number of moles of sodium chloride? So this is mass over what? Molar mass, right? So we're told that 4 kg of sodium chloride was used. So we know that we don't need kgs, we need what? Grams. So we're going to change this into grams. What do we do to change this into grams?
Times.
Multiply. Multiply by what? 1,000. So this is 4,000 grams. And this becomes how many? 3,000 grams. So what is the molar mass of sodium chloride? 58,5, right? Yes. So the number of moles now becomes 4,000 divided by what? 58,5. What do you get? What do you get? Guys, what's wrong?
I'm going to separate. I'm going to show never one minute. Wait for 4,000.
Yes, 4,000.
68,38.
68,38 moles, right? So these are the number of moles of what? Of sodium, right? So now let's go to the number of moles of what? Of this now. So number of moles is equals to mass over molar mass. So what is the number of moles there? What is our mass?
Mass is 3,000.
3,000 over the molar mass of water. What? 80. So it's not visible that size. So let's do like this. So it's 3,000 over what? 18. What do you find?
166,67.
Comma? 6. These are the number of moles of what? Of water, right? 167 point that. Now we are going to compare the two, right? But comparing, I said we compare using the what? The ratios that they are in, right? They must be in their what? Simplest forms. So this one is 1 there. So it is okay, right? But what about sodium chloride there now? Sodium chloride there it is 2. 2 now. So it means that we must do what? Divide this into, divide this by what? By 2, ne? But already, like just like that, we can see that because if we divide this, it will be still a small number, right? Is this making sense?
Yes.
So it means that our sodium chloride is the what? Limiting reagent. So this will limit our what? Our reaction, right? So it is sodium chloride, our what? Our limiting reagent. Now we are going to see, yes. So you can write that NaCl is the limiting reagent. Yes. So after finding our limiting reagent, it means that we can use our limiting reagent to do what? To find out the product of that, right? So what reaction are these happening on? 2s2, 2. So it means that 2 number of moles there and 2 number of moles there. So it means that if this is 1 number of moles there, it is going to create how many that side? 1, right? If it is 30, this side is going to create what that side? 30 as well, right? So if that's the case, it means that the same number of moles here are going to create the same number of moles that side. So what can we do? We can find the what? We can find the mass, right? By first finding the what? The number of moles. So it means that NaCl S2 NaOH, they happen on 1s2 1, right? So it means that this side it is 68, that side is also 68. So it means the number of moles of sodium hydroxide will be equals to 68.38 mole, right? So now we can find the maximum mass that can be created that side. And I'm loving the fact that they used the maximum mass. Why did they use the maximum? Why did they say the maximum? Why did they say the maximum?
The mass of the whole reaction.
Why did they say the maximum? Kuliso, what do you think? They didn't want the minimum. Actually, no. Ne? The reason why they said the maximum, it is because now we are using theoretically to calculate, right? We are using theory to calculate, right? So using whatever that you know theoretically to, theoretically to do what? To calculate, right? So it means that sometimes theoretically cannot be the same as the actual percentage or the actual mass that you are going to get when you are doing the experiment practically, right? Do you understand that? That's why at the following chapters we are going to do what? Theoretical yield and whatsoever, right? Percentage yield, right? Because most of the time, the ones that we calculate theoretically is not the same as the one that we are going to find actually, right? Is this making sense? So let's try to calculate the maximum mass that we can find theoretically, right? So we know that our number of moles is equal to mass over molar mass, right? So our number of moles here, it is 68,38. And what about our molar mass of sodium hydroxide? Sodium hydroxide, it is 23 plus 16 plus 1. Is it 40? 40 grams per mole, right? So now we can say our number of moles being 68.38 because to mass over our molar mass, which is 40, right? So our mass will be equals to 40 multiplied by 68.38. What do you get? 2,735.2 grams, which is the same as 2.735 kg, right? Something like that. So this is the maximum amount of mass that you can create from that, or the maximum mass that you can create. Yeah? Yes. Yes, we find the answer in grams, and then it depends if they ask you now to give your answer in kgs, so it means that you're just dividing the what? The grams by 1,000 to find your what? Your kgs. Is this making sense? Is this making sense? What is the time? What is the time? Okay, we are going to end here. Ne? So it means that the rest we're going to do when? We're going to do when the rest? When are we going to do the rest? Ulu, when are we going to do the rest? Why tonight?
Tonight.
Did you understand?
Tonight.
Did you understand?
Yeah.
Did you understand?
Yeah, understand. Yeah.
It was,
Okay.
it was super.